If you think about a function like f of x equals x squared, and you want more than just this abstract view of the function f of x equals x squared, you would actually like to know what this function looks like. In other words, as you put in values for x, what do the f of x values look like? In other words, what is the behavior of those values? Are they always getting bigger and bigger and bigger? Are they getting smaller and smaller and smaller? What's happening with those values? So one of the ways we can do that to help us to understand this function a little better is to graph the values. Let me show you what I'm talking about. Let's suppose that we want to find this value, f of -1. Well, of course, -1 squared is 1, and we get this ordered pair. X is -1, y is 1. Now, we could plot that down here on the xy axis. Here's the x and here's the y. We could plot that, and we get a point right there. We could do the same thing for f of 1. Plot that point. And we could do this for any number of points. See? We're just picking a few here. And of course, I could pick 0. 0 squared is 0, and it'd be down here. But if we keep going, and there's literally an infinite number of x values that we could plug in, if we put the more function values we evaluate, the more points we generate, the more we can see the shape of the function. In other words, if we connect all these values, there's an infinite number of values here, what we would get is a curve like this. And for this particular function, f of x equals x squared, that's what it looks like. So when we talk about graphing a function, that's what we're talking about. We have as the x-coordinate as the inputs is the x-coordinate, the outputs is the y-coordinates. Okay, so we generate these ordered pairs, and it's just natural. It's a natural way to follow evaluating a function. Plot the point. Now, there are a number of functions that we refer to oftentimes in college algebra, and we call these the parent functions. And these are, here I've listed 6. There are more than this that we'll add to our repertoire as we go along, but these are just some basic ones. Here we have a constant function, f of x equals 3 or something like that. That would just be a horizontal line. F of x equals x, it's just a line, y equals x. The absolute value function looks like this, it's just a v. And we'll refer to these as we go along. But right now, just become familiar with them, the basic shape. So if someone says x squared, okay, that's something that looks like this, okay? X cubed, like this, and the square root of x. Notice the square root of x has a limited domain. We can't have x to be less than 0. So notice the graph of that function doesn't even exist over here. So anyway, when we talk about the graph of a function, this is what we're talking about. It's a graphical representation of the values, the output values of the function. Now, let's think about a piecewise function like this one here. Okay? Now, this function right here, if we were to graph it, the graph would look like this. Notice, because what we're saying is f of x equals -x as long as x is less than 0. So if you look over here at 0 and say, okay, all over here, less than 0, I'm going to graph this as -x. So y equals -x. That's just like this. That's the graph of that function. Now, if we go to the right of 0, if x is greater than or equal to 0, then we want to graph x squared plus 2. And that's what this graph would look like. Now, we'll study, the reason this is x squared plus 2 will become more clear in future videos. But this is, just for now, we can just take it as given that this right here is the graph of this function. And when you have a piecewise function, it's probably going to look something like this. Notice I've got an open circle here at 0 because the graph f of x equals -x, That's defined for x strictly less than 0. Now, when we actually get to 0, we jump all the way up to 2. See? If we put a 0 in here, we get a 2. Now, we have other functions like this one here. Okay? So this tells us if x is less than -2, we got negative-x. So it looks like this. And notice there's an open circle here because at -2, we're going to jump up to 3. See? So between -2 and 2, inclusive, it's this. It's just f of x equals 3. And then for x greater than 2, we're back down to the line. See? We're at this line. F of x equals x. This part of it. Now, of course, if you graph the whole line y equals x, it would go all the way down here and pass through the origin. If you graphed y equals -x all the way, it would go down here and pass through the origin. But we have the limited domain here. So that's what this graph looks like. So that's what a piecewise function looks like.